going to guide you through two of the most common problems that we see in algebra, which is related to factoring. So we're talking about factoring today. I created this factor map. You may pause the video and look at it. And it describes the different methods that we can use to factor. So yeah, we're going to look at a trinomial where a is 1 and where a is not 1. So we'll look at AC method, and we'll look at the method described in this box here. So you may pause it and take a look at that. So let's go ahead and let's factor this, and I'll describe how we would factor this. X squared minus 4x plus 3 is we'd find two numbers, okay? Two numbers that multiply to 3, so that's this value, and add to negative 4. And in fact, those numbers will be integers, okay? So numbers like -2, -1, etc. So here it's not too complex. The two integers are -3 and -1, because this is true. Okay, they multiply to 3 and they add to -4. So when we go ahead and we factor this into a product two binomial factors, you know, x goes in the first slot and these two integers will go in the next one. And we could always FOIL first, outer, inner, last to check. And if we FOIL that, we get x squared minus x minus 3x plus 3, which is x squared minus 4x plus 3. So it's a check, okay? So this is how we would factor a trinomial where the leading coefficient is 1, all right? Provided that we have integers as the numbers that multiply to c, that's this value 3, and add to b, which is this value -4, okay? So now let's look at one more example where that leading coefficient is not 1, okay? So that leading coefficient is 2 now. So what we'd need to do is, if possible, find two integers, two numbers, right? We'd like to find integers that multiply to AC using the AC method, which here would be 2 and 5. Remember, this is the same thing as ax squared plus bx plus c, right? Which is 10 and adds to -4, okay? Now, what are our options? This one is not as obvious, perhaps, right? So we list out the factors of 10. How do we get to the factors of 10? Well, we just see what numbers or integers divide into 10 evenly. 1, 2, 5, and 10. Now, no matter what I do, any combination, whether it be positive or negative, of these numbers, while it multiplies to 10, does not add to -4. For example, if I took 1 and 10, 1 times 10 is 10, but we know 1 plus 10 is 11, which is not equal to -4, right? So we need an alternate method to factor this because the AC method doesn't function, doesn't work. So there's one other method that we could choose, and that's pretty commonly used, and that's to solve this quadratic equation using a quadratic formula. So if you're familiar or not, this is the quadratic formula. It comes from the method of completing the square, which we're not going to talk about here. And we plug in the numbers, the coefficients here, and see what we get, okay? So we'll plug in those numbers, okay? And in this scenario, AC method wasn't working because we'll see why shortly. 2 times 2 on the denominator. And what we get is the b squared minus 4 times a times c. We get that this is a negative number in here, right? And we know the square root of negative number does not exist as a real number. This is going to be an imaginary or complex number, x. So so we can conclude this problem that x squared, 2x squared minus 4x plus 5 is not factorable over the real numbers. So it is already in factored form over the real numbers. So this is, to conclude, in factored form over real numbers. Over R, which is the real number system. And excuse my sloppy writing here. So it's already factored over R. Okay, that's R with a slash in it. That means real number system. So it's already factored, which means it's already in the simplest form. Okay, in simplest form. Over the real number system. So this is it. Okay.